This is our Fasc group project where we will be first attempting to prove Archimedes' principle. Archimedes' principle states that sum of weight of object in water and weight of displaced water equals weight of object in air. So, we will be testing and proving this theory. These are the equipment you will need. Firstly, a drill and an empty bucket. First, drill a hole near the surface of a bucket according to the diameter of the straw used. Then, you will need to hot glue the straw on the hole to prevent any water from escaping. This will form our Eureka can. We will use weights as an object and electronic weight spring. Now, pour water into the bucket until the water level reaches just above the straw and allow excess water to flow out into the container on the left. Tie the object to the electronic weight spring and record its weight on air and in water when submerged, and also record the weight of the displaced water. We have repeated this 10 times and increased the mass of weights during subsequent attempts.
From the experiment, we can conclude that the sum of weight of object in water and weight of displaced water is equal to the weight of object in air.
Next, we will be seeing how buoyancy force affects the behavior of an object in water. Buoyancy force is an outward force exerted on the object by a fluid when it's immersed in it. Let's now prove the buoyancy force with our custom-made submarine. So you'll need a couple of straws, a small container, a hot glue gun, a drill, and a silicone. First, you will need to drill 2 equally spaced holes on the cover and insert 2 straws through. Now secure the straws with the silicone and a layer of hot glue to prevent any air from escaping when it's immersed in the water. Attach the 2 small weights at the bottom, and it represents the weight of the missionary and people in the actual submarine, and extend the length of the straw by connecting them together.
Welcome to our FASC project, where we have created a submarine, a scaled-down version of how a submarine operates. So as you can see, this is how the submarine is built. This weight here indicates the missionaries and people inside the submarine, so it indicates by the weight. So we have 2 tubes. The first tube is where air will be blown into the submarine, and the second tube is where water will escape as air is entering the submarine. So we will see how does air to water ratio affect the behavior of a submarine. So I want to get into the water. Right.
So you can see it floats. Currently it's floating, but eventually it sinks because the water enters the submarine. So how do I make this submarine float? Again, I rise up. I'll blow this. I'll blow air inside this tube, and then air will enter this submarine, and this will cause the submarine to float. So here we go.
So you can see air is now taking up space in the submarine, pushing the water that had initially entered the submarine. Therefore, it causes it to rise up to the surface again.
As we saw in the video, the submarine sinks when the volume of air in the container decreases, weakening the buoyancy force, and rises when the volume of air increases, strengthening the buoyancy force. This shows volume of air immersed in the water is directly proportional to the buoyancy force.